Millions of years ago, the planet was ruled by huge reptiles. From long-necked Brontosaurus chewing on leaves to Tyrannosaurus rex hunting with deadly accuracy, dinosaurs roamed the Earth for at least 230 million years. But 66 million years ago, a catastrophic event happened that changed the world forever. Ever since, scientists have been trying to uncover what happened. But before we start, smash the like button and make sure to subscribe if you haven't, and hit that notification bell so that you won't miss any new stories. After drilling into the Chicxulub crater, researchers made a mind-blowing scientific discovery about the day dinosaurs were wiped out forever. Their findings would change everything we once thought we knew about that day. For billions of years, a huge asteroid floated in orbit in the vast expanse of space somewhere between Mars and Jupiter. Meanwhile, our fragile planet was flourishing with life, but then some celestial event pushed the huge space rock out of orbit, sending it plummeting toward Earth at a speed of 45,000 miles per hour. It collided with a shallow sulfur shelf in what is now called the Gulf of Mexico, causing untold devastation across the Earth. The dinosaurs had met their maker, but how and why did they become extinct? And just where did the asteroid come from? One theory suggests that the asteroid was formed when a huge space rock from a cloud of debris known as the Oort cloud was knocked off course by Jupiter's gravitational force. This larger comet, known as a sun grazer, broke into pieces as it orbited the sun, making it statistically more likely to make contact with the Earth. Fortunately, this kind of collision happens only once every 250 to 730 million years or so. But when it does, the impact is catastrophic. When the asteroid hit the Earth, it created a crater approximately 110 miles in diameter and 12 miles deep, tearing fault lines all the way down to the Earth's rocky mantle. The gaping chasm quickly filled back up with geological material, creating a huge ring of peaks around the edge that is still intact today. Debris from the impact covered the entire planet, and that wasn't the only effect of the collision. Following the strike, the geological fallout could be felt all over the planet. Magnitude 12 earthquakes shook the region surrounding the impact site, and cliffs tumbled into the sea. Hurricane-force winds battered the whole of North America, vaporizing everything in their path. Within hours, tsunami-sized waves battered the coast. Wildfires raged, transforming the Earth's plant coverage into a thick layer of soot. Acid rain fell from the sky. The reptilian inhabitants of the planet were now living and dying in a kind of apocalypse. Most scientists agree that this was the decisive event that led to the extinction of the dinosaurs. With the planet enveloped in sulfur and dust, effectively blocking out the sun, photosynthesis all but stopped. In these new, cold, dark, and lifeless conditions, 3/4 of life on Earth was wiped out, leaving behind only a few of the most resilient and smaller forms of wildlife. This theory of extinction is known as the Alvarez hypothesis, named for father and son duo Luis and Walter Alvarez, who posited that the layer of iridium, a rare element found in abundance in meteorites on the Earth's surface, was evidence of a catastrophic asteroid collision. But it wasn't until the 1990s that scientists pinpointed the actual collision site. Although the Alvarez hypothesis provided the groundwork, it didn't provide any details to help locate the site of the asteroid crash. However, there were many markers that started pointing scientists toward the missing crater. Sediment from ancient tsunamis was found in Texas and tektites, small pebble-like glassy objects of Earth material that have been melted by meteorite impact, and fallen back to Earth were discovered in Haiti. With these geological clues, it was only a matter of time before the crater was located. The impact crater, known as Chicxulub, named after the nearby town, was discovered by two geophysicists who had been looking for petroleum in the Yucatan Peninsula during the late 1970s. Initially, they weren't able to find evidence that the site was a crater, so they gave up. But in 1990, geological evidence emerged, such as shocked quartz, that proved that the huge circular underwater feature was indeed an impact site. Its location on a sulfur-rich shelf helped to explain the environmental chaos. However, many questions remain. Now, scientists could finally start to learn more about the event that wiped out the dinosaurs and reshape the history of the planet. There was a lot of work to do. What exactly happened on the day of the collision? How did the peak ring form around the edge of the crater? And what were the first life forms to begin flourishing again after the calamitous event, leading to the most significant evolutionary sea change for mankind? The rise of mammals. Experts pondered these fundamental questions. One of the leading scientists interested in the Chicxulub crater is Joanna Morgan, an award-winning professor of geophysics at Imperial College London. She's an expert seismologist who first started working on experiments in the crater in the mid-1990s and has dedicated her career to learning as much as she can about this catastrophic event. It's the most important natural event on Earth in the last 100 million years. It changed the course of evolution, Morgan told Discover magazine. If the researchers can find those first species to recolonize the crater, the discovery could teach us not only more about the dinosaurs' demise, but also how life survived similar events billions of years earlier. She continued, In 1994, Morgan heard the arguments between two geologists, Alan Hildebrand of the University of Calgary and Buck Sharpton of the Lunar and Planetary Institute in Houston. As they disagreed over details about the crater, the young scientists decided to take a chance. In 1996, Morgan started a groundbreaking seismic study at the crater site. Her team towed a large air gun behind their research boat, blasting the seafloor with seismic waves that bounced back, revealing a clearer picture of the crater and determining its size for the first time. But she wasn't going to stop there. Morgan's next research step was going to be even more revolutionary. She intended to drill into the crater. Drilling would reveal the layers of sediment and geological evidence needed to pinpoint exactly what happened on that fateful day, including the peak ring formation and the wider environmental impact. Morgan asked the International Ocean Discovery Program, IODP, for $100 million worth of funding to collect 6 2-meter deep cores from the center of the Chicxulub crater, according to Discover magazine. However, the IODP rejected Morgan's proposal until she could lower the cost of the project. $100 million was an enormous amount of money, and the Marine Research Group just didn't have the funds. They also commissioned a 3-dimensional site survey of the area in 2005 before they would consider the proposal. They partnered with Shah Gulick, a geophysicist at the University of Texas. Once again, air guns were towed around the shallow gulf, this time revealing enough seismic information to map the Chicxulub crater's exact shape and topography. However, Morgan's plan was still too expensive, and she was forced to put it on the back burner. Another part of Morgan's research had to do with the forest fires that engulfed the Earth after the asteroid hit. For years, many scientists had assumed that the fires had occurred because the atmosphere following the strike had superheated the planet, causing fireballs to fall from the sky like rain. However, scientist David Kring of the Lunar and Planetary Institute had other ideas. He suggested that it was more likely for the forest fires to have been regional and less all-encompassing, igniting from a thermal pulse near the impact site and spreading outwards. Morgan and her team decided to put Kring's theory to the test. Back in the lab in London, Morgan experimented with setting pine needles on fire and demonstrated that the thermal pulse wouldn't have been hot enough to ignite the kind of wildfires associated with the asteroid. Instead, Morgan posited that the dry forest litter would have been the starting point of the fires, and that the reduced sunlight and falling debris would have had the greatest impact on the Earth's plant life. What's more, the fossil records show that there was a huge shift in plant populations following these widespread forest fires. Evergreens like pines that were widespread before the asteroid were wiped out, while deciduous tree species, those that shed their leaves yearly, were much more successful at bouncing back. Fossil evidence also shows the survival of spores and seeds amid the wreckage, leading to an intriguing hypothesis about the few survivors of the mass extinction. Certain species of avian dinosaurs about 150 million years ago in the Jurassic period, the first birds evolved from small, feathery, raptor-like dinosaurs. These avian dinosaurs evolved to become the birds we know and love today, and were the only dinosaur descendants to survive the collision. Scientists posit that these winged dinosaurs survived because of one very specific advantage: their beaks. Beaked avian dinosaurs could feast on the seeds and spores left behind in the wildfires, even after food had run out for the carnivores and the herbivores. Despite these breakthroughs in paleontology and paleobotany, Morgan was still desperate to get her drilling project off the ground. In 2016, 2 decades after she first proposed it, a downturn in the oil economy dropped the project cost to $10 million. In April, the diamond-tipped drill bit sank into the crater floor to retrieve geological material containing secrets from 66 million years ago. Working in extreme heat, the team extracted 10-foot sections of core, recording time-sensitive data such as density and temperature before sending the samples away. Over more than 2 months, the team collected half a mile of core, with Gulick describing the experience as amazing. The cylinders were sent to the IODP's repository lab in Bremen, Germany, for analysis by a 33-person team. The results provided a clearer picture of what happened on the day the asteroid struck Earth. One of the most remarkable discoveries was the speed at which new geological material was deposited. The ocean floor reacted like liquid, forming a tall peak that collapsed into a peak ring. Over 430 feet of debris settled in just one day. Achieving this level of geological precision was unprecedented. Commenting on the findings, Smithsonian Director Kirk Johnson noted the data finally confirmed long-held theories with solid evidence. This research gave scientists rare insight into the vulnerabilities of life on Earth and showed how short-term violent events leave lasting marks. Morgan's work at the Chicxulub crater solidified the theory that an asteroid struck the Gulf of Mexico 66 million years ago, wiping out 75% of life. The question arises, could it happen again? If dinosaurs didn't survive, would humans? Scientists don't foresee another Chicxulub-sized impact anytime soon. Such events are thought to occur only once every 100 million years. Still, smaller impacts remain possible. Studying the Chicxulub crater serves as a powerful reminder of Earth's vulnerability to cosmic forces. It offers insight into life's resilience and the fine line between survival and extinction. By learning from the past and preparing for the future, we can ensure the continued survival and flourishing of life on Earth for generations to come. We can't wait to see what scientists uncover about dinosaurs in the future.